The overall goal of this procedure is to induce a venous thrombus in mice using an electrolytic inferior vena cava model. This is accomplished by first opening the abdominal cavity to expose the inferior vena cava, or IVC. Next, the IVC side branches are ligated. Then an anode and cathode are inserted, and a current is applied to induce a thrombus. Finally, the animal is closed and allowed to recuperate. Ultimately, results can be obtained that show a venous thrombus formed within the mouse IVC in the presence of blood flow and a correlation between the levels of P-selectin and the size of the thrombus in different mouse strains.
Dr. Lucchesi published the concept of this technique in 1980 and used it successfully in the arterial system. When I joined the lab at the University of Michigan, I was assigned to modify this original technique to be used in the vein system. During this process, I thought to insert the needle close to the origin of the IVC based on the direction of the flow.
To induce deep venous thrombosis in a mouse, begin by anesthetizing the animal in a preoperative induction chamber with 5% isoflurane and 100% oxygen at a rate of 0.5 liters per minute. After the mouse is sedated, remove it from the induction chamber. Shave the ventral abdomen with electric clippers. Next, weigh the mouse, then apply ophthalmic ointment and place it on its back on a warm water circulating heating pad under general anesthesia with isoflurane and 100% oxygen. To disinfect the incision area, spray the abdomen with chlorhexidine solution and wipe with sterile gauze. Do this 3 times or until the surgical site is clean. To begin surgery, make a 2 cm ventral midline incision with iris scissors through the skin and abdominal wall, exposing the abdomen. Use a sterile saline-soaked 2 by 2 inch piece of gauze to deflect the intestines to the animal's left side. Then secure a mouse restrainer in place to expose the inferior vena cava, or IVC. From this point forward, use a maintenance level of 2% isoflurane and 0.2 liters per minute oxygen. Use a sterile applicator swab and extra delicate iris half-curved tissue forceps to perform blunt dissection of the fascia on both sides of the IVC to allow complete access to the IVC and its branches. Note that a lymphatic node is close by and can be used as a landmark to find the caudal IVC. Using 7-0 non-reactive proline sutures, ligate all IVC side branches from the renal veins to the iliac bifurcation. Allow the back branches to remain open. Next, insert a 25-gauge stainless steel needle attached to a silver-coated copper wire into the exposed caudal IVC and position it against the anterior wall. This is the anode. Then, implant another needle with a wire subcutaneously, completing the circuit. This is the cathode. Using a Grass S48 square wave stimulator and a constant current unit, apply a current of 250 microamps over 15 minutes. This will erode the endothelial surface of the IVC and form a thrombus. For control animals, insert the needle into the IVC for 15 minutes without applying current. Minimal changes, such as little black spots close to the needle, are usually observed during the procedure, confirming the success of the procedure. After 15 minutes, remove the needle by lowering the needle dorsally and allowing blood to refill the lumen of the IVC around the needle. Using a cotton swab above the needle entry point, press down on the vein as you remove the needle. Gently apply pressure with the cotton swab until the bleeding stops. To close the laparotomy site, use a 5-0 Vicryl synthetic suture in a continuous pattern to close the abdominal wall. Then apply adhesive glue to close the skin. Allow the mice to recover in individual cages under a heating lamp and monitor them closely before returning them to their original housing units. The EIM is a model that forms a thrombus in the presence of continuous blood flow. The following figures show parameters investigated in this novel model. Here, thrombus weight, which is a measurement of thrombus size, is presented in mouse strains 2 days after EIM. As expected, thrombus weight was lower in PAI-1 knockout mice, which are known to have increased fibrinolysis and consecutively develop a small thrombus, and higher in hypercoagulable delta CT mice. Using an ELISA, soluble P-selectin, a marker for deep vein thrombosis, was measured in different strains. The lowest levels were found in PAI-1 knockout mice, whereas the highest levels were found in hypercoagulable delta CT mice. This graph shows the correlation between thrombus weight and soluble p-selectin found in different mouse strains. In the PAI1 knockout mice that generated the shorter thrombus size, the soluble p-selectin detected was the lowest, while the delta CT mice generated the largest thrombus size, and their levels of soluble p-selectin detected were the highest. In order to demonstrate the presence of blood flow, ultrasound was performed in mice undergoing EIM. This figure shows the ultrasound results from a mouse 2 days after EIM. Note that the thrombus shape suggests it was formed in the presence of flow.
During this procedure, it's important to be aware of our patient at all times. Hypothermia is the most important factor that can severely affect the animal in his postoperatory period, jeopardizing his life and your research.